9-2, we are moving on. We are doing prime factorization today. So make sure if you're at home, make sure you're taking notes in your 3-ring binder. Label this 9-2 prime factorization, and then do the examples, write down the definitions with us, and then do your 9-2 homework, which it's odds only. All right, so first some definitions. Now, the book had a very long-winded definition. I've tried to clean it up a little bit to make it a little less long-winded. So these are the 3 definitions I want you to have down. The box is kind of the book's long-winded definition. I summed it up a little bit more. A prime number is exactly 2 factors, 1 times itself. Okay, that's a prime number. And I think you've been dealing with prime numbers for quite a while now. 7. Yes, 7 is a prime number. Composite numbers are numbers that have 2 or that have more than 2 factors. So not just 1 in itself, but then it's also divisible by 2, 3, 4, 5, you name it. It has more than 2 factors. And then the last thing I want you to write down is what is a monomial, because that's a term we're going to use a lot. And it really is just a fancy word that means 1 term. Okay, a single term. And I'm going to show you here in a second some examples of monomials that may not even look like monomials, but I'll tell you why they are. And then I'll show you some examples of things that are not monomials. All right, everybody have those down? So a prime number, just as a review, a prime number has exactly 2 factors, okay? 1 in itself. It's the only 2 numbers that will multiply together to give you the number. And then a composite number has more than 2. So it's divisible by more than just 1 in itself, right? And then a monomial means 1 term. Mono means 1. So I want to give you some examples here kind of off to the side of some terms, and I want to see if you think they're monomials, okay? So how about if I just write a 2? Is that a monomial or a single term? 1 term. Everybody good with that being just 1 term? How about if I say the variable x? Is that 1 term? Yep, just a single 1 term, right? What if I give you 3m? Is that a monomial? It's a trick question. It's a 3 and an m, so your knee-jerk reaction is nope, that's not a single term. But do you guys remember the little memory trick I told you? How is the 3 and the m connected right now? Multiplication. What's the little memory thing I told you about multiplication? It's like what? Marriage. 2 become 1. They are married. If they're multiplied together, they're married. 2 become 1. That is considered a monomial. Okay. So it doesn't matter how crazy you get. You could have, you could have 5am dzYxw. Is that a monomial? Doesn't look like it is, right? Because there's so many terms there, but they're not individual terms. They're multiplied, which means they're married, right? They are 1. So this is considered a monomial, even though it's long and there's a lot of things involved. It's still a monomial because it's 1. Where you break loose and you no longer have a monomial is where you have something like this. This right here, that's what breaks it. This is a monomial plus a monomial, okay? This is a monomial plus a monomial, okay? 1 term, 1 term. The 2 together is not considered a monomial because of the plus and minus sign. That's kind of what breaks that link, that marriage link, okay? Are we good with those terms? Because we're going to use that terminology quite a bit in this lesson. So prime factors, composite number, or prime number, composite number, monomial, those are going to be kind of some of the terms that we go with. Examples of prime numbers, you guys should be pretty familiar with this. 2, 3, 5, what's after that? 7. Not 9. 9 is 3 times 3. What's after 7? Yeah, 11, 13, 17. I heard somebody whisper it. 19. And the next one up is as high as we'll go. Anybody know the next one up? 20, nope, 22 could be 2 and 11. 23, yep. That's about as high as you guys are going to need to know. But yes, those are prime factors, okay? And it means that for the number 2, there are no other 2 numbers that multiply together to give you 2 except 1 and 2, right? 1 times 3, 1 times 5, 1 times 7. There are no other factors. And when I say factors, I mean 2 numbers. Well, it doesn't have to necessarily be 2, but at least 2 numbers multiplied together to give you a third term. So for composite numbers like 4, right? 1 times 4 is 4, but 2 times 2 is also 4. So it has more than just the 1 in itself. 6, 1 and 6, but then it also has 2 and 3. It's a pair or a group of numbers that when you multiply them together, they give you that term. 8, you've got 1 times 8, 2 times 4. And when you start getting up there in like 12, you could have 1 and 12, 2 and 6, or 3 and 4. So there's a lot of different options there. Okay. All right. So today we are going to be first talking about whether or not a number is prime or composite. Okay. And I am fine. You know me, this is math, not language. I am good with P or C. Okay. Prime or composite. So if you're not sure, you've got to run through kind of the possibilities of what could it be divided by. And I'm going to give you a couple of little memory tricks to help with that. Okay. So 11, we've already listed 11 is a prime number, right? The only thing that gives you 11 is 1 times 11. So 11 is a prime number, okay? How about 63? Obviously, we know 1 and 63, but we need to test to see if it could be divisible by 2, by 3, by 5, right? So 1 in the number, we don't even have to test that because that has nothing to do with prime or composite. Is this divisible by 2? Without any math, just glancing at it, how do you know? It's an odd number. So if it's an even number, boom, it cannot be a prime number. Because if it's an even number, it's divisible by 1 in itself. And if it's even, it's divisible by 2 and something else. So every even number right off the bat is going to be composite. How about the rule of 3s? Can you look at a number no matter how big it is and see whether or not it's divisible by 3? What's the rule? Anybody know? Blake? Not just the front one. Add up all the digits. So here, 6 plus 3. Yeah, 6 plus 3 is 9. Since 9 is divisible by 3, 63 will be divisible by 3. And it doesn't matter how big of a number is. I could give you like 1,200,346,000, and you could just add up all those digits. And if that's too big of a number, add up those digits until you get to a number that you know whether or not it's divisible by 3. And you can tell any number without ever touching a calculator if it's divisible by 3. Okay. How about 5s? What's the rule of 5s? If it's divisible by 5, what's it end in? A 0 or a 5. Okay. So you can really do a lot of mental checks here. Now, 7, there's no rule. So if I were you, if you're not sure, punch in your calculator 83 divided by 7, right? If you're not sure about 83, I can tell you right off the bat, it's not divisible by 2 because it's odd. I can tell you it's not divisible by 3 because 8 plus 3 is 11, and 11 is not divisible by 3, so 83 will not be. It doesn't end in a 0 or 5, so I can check off 2, 3, and 5 right off the bat. There's no real cool memory trick for 7. So I would just punch in my calculator 83 divided by 7 and just try it. If it comes out even, then you know it's divisible by 7. If it doesn't come out even, then it's not. Because this is all prime factorization, and factors, that's all whole numbers. You don't want to deal with any decimals, okay? And then, you know, the next one up is 11. And it can't be 11 because if it was an 11, it would have to be 88. So pretty much, if you get up to trying, really the only ones you're going to have to punch in your calculator and try are 7 and maybe 13. Okay. Other than that, I think you're going to be pretty good at the mental ways to do it. Okay. So using those kind of mental tricks that we just talked about, we've already decided that 63 is divisible by what? 3. So that means it's divisible by more than just 1 in the number. So it's composite. How about 75? It ends in a 5. So what do we know it's divisible by? 5. So since it's divisible by something other than 1 in itself, it's composite. How about 69? It's not even, so it's not 2. How about the 3 rule? Yeah, 6 plus 9 is 15. If you're not sure about 15, add 1 plus 5 and you get 6. It's divisible by 3. So that one would be composite. How about 83? Doesn't pass the 2 rule.
So I do have a question for you.
Yeah.
So can you go back to like number 1?
Yeah.
11? So would we have to write 1 in that?
No, I was just showing you kind of what my thinking was.
Okay.
Yeah. Yep. So how about 83? It's not even. How about the 3 rule? 8 plus 3 is 11. So it's not going to be divisible by 3. It doesn't end in a 0 or 5. We already checked. We divided it by 7. That didn't work. You can divide it by 11, but it doesn't. It's not 88. You can try 13. That doesn't work. You pretty much ran the gamut of your, I mean, you haven't, there's bigger numbers that you can use, but not a number the size of 83. You're not going to have that big of prime numbers. I mean, you could take 23 times, what's another prime number? 31 prime? Yeah. You could take 23 times 31 and you could get some giant massive number. And it would be hard to find out whether or not, just through easy math, it would be hard to find out whether that big number was prime or composite, but you could do it by just running through all your prime numbers and just continually trying to divide it by a prime number. And eventually you'll get that 23 times 31 is the big number. But with these littler numbers, you don't really need to go any higher than 13. Okay. All right. I think you guys get the gist there. 73. What do you guys think? Prime or not? Prime or composite? Prime. Yep. Doesn't pass the 2 rule, the 3 rule, the 5 rule. You can try 7, but it's not going to work. How about 49? Composite, because 7 and 7, right? How about 53? Prime. 2 rule, 3 rule, 5 rule. You can try 7, but hopefully you know you're at least 7s up through 70. So we're good. That's the top half of your homework. So really watch your directions. Okay. The top half of your homework just says determine whether it's prime or composite. I'm good with P and C. Okay. Now the middle part of your homework. I'm such a nerd. This is my absolute favorite thing to do in math. This is what made me want to be a math teacher. I'm not kidding. And I used to do this for fun when I was a kid. I'd make up some giant number and I'd factor it all the way down to primes because I thought it was fun. So there you go. A glimpse into your total math nerd teacher. Miss Borden? Yeah, I do. All right, thanks. Okay, so prime factorization. We want to break down a number, okay, into factors, but we are never going to use 1 in the number. That's a given for every single number on the planet. We do not need to start with 1 in the number. So to factor a number, okay, and you guys have done factor trees before. So you're going to start with the number, and then you want to find 2 numbers that when you multiply them together, you get 33. Now, I know you guys have done this before, but I want to show you kind of a specific way I want you to do them, because you might have done factorization before in previous years, but this year we're going to kind of add a little to it. So there's a very specific way or order that I want you to do it, and it's going to make your step 2 a lot easier. And I'll show you what I mean. Okay. And this first one isn't really a good example, but I just wanted to show you. So when you factor these, and did I erase it? I did. So the little note I want you to write to yourself, okay, is that when you're factoring a number, any number, okay, on the left, which is this side right here, and I'll do it in red, on this side right here, you always use a prime number. Okay. And I'll explain this more. I promise it'll make more sense when we go through it. Keep using each prime as long as you can. And that'll make more sense when we go through it here. So when you branch out your number to factor it, I want you to always use a prime number on the left. Okay, I don't care what prime number. If you can recognize right off the bat, it's divisible by 5, you can start with 5. But what I mean by stay with 5 is that if 5 is that branch, and then you're gonna, on the other branch, you're gonna put what times 5 gives you the number above it. Then you're gonna move to that number and you're gonna branch again. On the left again, I want you to stay with 5 if you can. If it's divisible by 5 again, do 5 again. If it's divisible by 5 again, do 5 again. Then maybe you get to where it's not divisible by 5 anymore and you got to try 2 or 3. Once you try 2, stick with 2 as long as it's even. And then you may need to jump to a 3. And I'll show you why, okay? It's really easy. It'll make today's assignment so much easier, keeping all your 5s together, all your 2s together, and all your 3s together, okay? So hopefully as we go through this, it'll make more sense. All right, so doing 33. In going with what I just now said, on the left, I want to only use a prime number. So I can try 2, but it's not even, right? So I'm going to jump to 3, and I know 3 is going to work for me. And what times 3 gives me 33? 11, right? 11 is also prime, so I can stop. So my answer, because it says, notice here, there's a couple of things in the instructions. It says, write the prime factorization of each number, but then here, there's more. Use exponents for repeated factors. Well, we learned that yesterday, okay? Math builds on itself. That's what we talked about yesterday. If you have 3 2s, you would write it 2 to the 3rd, okay? So here we only have 1 3 and 1 11. So our answer is just 3 times 11. Those are the factors of 33, okay? Very small number, very easy to do. There was only 2, okay, 3 and 11. So how about if we take 72? Okay, that's the next one down here on the list, 72. Well, going by the method I want you guys to use, I want you to start on the left-hand side with either a 2, a 3, or a 5. A 7 maybe if it's a high enough number. It's even, so let's just start with 2. So if you're not sure, you can punch 72 divided by 2 in your calculator, okay? And the nice thing about doing it this way is, and this will save you guys time, you don't have to clear your calculators. If you punch 72 divided by 2 and hit equals, you're going to get 36. Don't clear your calculator and then hit 36 divided by 2. Just hit the divided sign again and hit 2 again. And you're going to get 18. Okay, divided again by 2. Remember, I know I'm sticking with 2s as long as I can, right? 2 times 9 is what gives me 18. Now I can't do 2 anymore. So I got to go to 3, and that's 3 and 3. Now I'm all prime, right? Now your answer is going to be written with exponents. So you look at, start with 2. How many do I have altogether? I have 3 of them. So there's my 2s. Okay, now look at your 3s. How many do I have altogether? I have 2 of them. That is your final answer. So in the past, you might have had your final answer 2 times 2 times 2 times 3 times 3. In 8th grade standards, they want you to get used to writing those with exponents. So it'd be 2 to the 3rd, 3 to the 2nd. Make sense? And that's why doing it the way that I'm having you do it, with always doing the prime number on the right or on the left and always sticking with it until you can't anymore, it just helps you keep all your numbers together so that writing your final answer is very simple because they're all grouped together, okay? And I'm going to show you an example here in a minute of when it can get very chaotic if you don't do it that way, all right? Don't be freaked out by big numbers. I want to show you this 1024, okay? Do not let the fact that it is a bigger number mess with you. It's even. So without even thought, where are we going to start? 2. Now, in your calculator, again, take 1024 divided by 2, and you're going to get 512. Is that still even? Okay, so I'm going to use 2 again. I'm not going to clear anything on my calculator. I'm just going to hit the divide sign again and hit 2 again. Good, and I get 256. Is it still even? Okay, keep going with the 2s. 2 times, what is it? 128. Still even? Okay, I must keep going with the 2. Still even? Okay, good. 32, still even. So I'm going to keep writing these 2s all the way down until I can't anymore. What is it now? Okay, 2 and 8, 2 and 4, Wow, this one factors all the way down to all 2s. Now, this is where you should say, man, I'm glad we get to write the answer with exponents so that I don't have to write 2 times 2 times 2 times 2 times 2 times 2 times blah, blah, blah. Okay, let's count them. How many, and here, and don't forget this one right here, all the way up to this one. This is what we're counting. Okay, all those 2s. So our answer here is going to be 2 to the what power? 1, 2, 3, 4, 5, 6, 7, 8, 9. Good. 10th power. And that's our answer. Don't let big numbers, they don't have to be hard. If they're even, try 2. Add up the digits, try 3. If they end in a 0 and or a 5, start with 5. Get all the 5s out that you can, then jump to the next one. Okay? You might. And I also I purposely didn't copy on the front and back. So I left your whole back side empty as well. So separate sheet of paper or the back side of your homework, I purposely left that blank for you to use if you need it. Just number which number it goes to. Okay. Now I want to show you really quickly, and then we're going to go back up to this factor monomial thing, but that's really easy. So I'm not going to spend a whole lot of time on that. I want to go back. I want to do this real quick. I want to show you the right way and the wrong way. Okay. Don't put this example down necessarily. Okay. The example on the right is the wrong way. Hopefully you can see why. When you go to write your answer, you got to start hunting all over the place, right? Where do I have a 5? Oh, where do I have a 2? Okay, so I've got a 5 here and a 5 here. I hope I found them all, right? I've got a 7. Hope I found that one. Now I've got a 3 and I've got a 2 and a 2. See how easy it is to miss this little guy up in here? That's what I mean by, will you get all of these same factors? Yes, you will. Okay. But let me show you the right way. Because it ends in a 0, I'm going to go with 5, right? Because that's my easiest one that I know. 6,300 divided by 5 is 1260. Okay. You guys have calculators. I still end in a 0. So I'm going to do 5 again because I'm sticking with the same one until I can't anymore. I get 252. Can I do 5 anymore? Okay, so now I'm going to jump to, doesn't matter, you can pick, it's even, I'm going to jump to 2. That's an easy one. Yeah, so I'm going to divide that by 2, and I'm going to get 126. It's still even, so I'm still going to stick with 2. What is it? Okay, I hit 63. Now I can't do 2 anymore. Let's try 3. Good. So 3 times 3 is 21, or 3 times 21 is 63. I can still do 3. Notice how much easier it is now, right? To identify 5 squared, to identify 2 squared, to identify 3 squared, and then to have that lone 7 that's the very last one. Notice here, I got 2 5s, 2 2s, 2 3s, and a 7. I got all of the same factors up in that messy one. But do you see how easy it would be to miss this little guy up in here when you're writing your final answer? Because he's tucked up and they're all out of order and they're scattered all around. So that's why I say do it in this order, okay? The last thing I want to show you on your homework is this bottom portion. Make sure you put a note that on the bottom, very bottom portion, it's no exponents, okay? So if you can do it without a factor tree like 35, okay, 35 is pretty straightforward. It's 5 times 7 times V. That's factored. Okay. Yep. For number 21 there, that negative 14B3, it's negative 2 times 7. Those are the factors. One of them has to be negative because it's negative 14. And then B times B times B. So no exponents in that bottom section. If it's a bigger number like 81 and you're not sure, factor it. 3 times 27, 3 times 9, 3 times 3. So the factors are negative. I need a negative. 3 times 3 times 3 times 3 times H, right? Because it's 2 H's. Okay. You have your packet with 9-2 in it. It's odds only. Check Canvas. If we're not here tomorrow in person, check Canvas. Make sure you know what to do tomorrow, and then check Canvas on Friday to make sure you know what to do on Friday. Okay. All right, for those of you at home, I will have a Google meeting open all day on Thursday and Friday if we have e-learning. So that Google meeting link will be on Canvas and you can jump on anytime to ask a question. If not, you can send me an email.